The GX-2009's sturdy, rubber, overmolded body is suitable for use in most environmental conditions. The unit is dust-proof and water-resistant. The rubber, overmolded surfaces on much of the case help protect it from impact damage and aid in gripping the instrument in your hand. A clear plastic window through which the LCD can be viewed is located on the front of the case. 3 gold-plated brass charging contacts that are used when the GX-2009 is placed in the charging station are on the back of the case. 4 sensor diffusion ports are located on the bottom of the case. The ports are labeled as H2S for hydrogen sulfide, CO for carbon monoxide, HC, which stands for hydrocarbons for the combustible channel, and O2 for oxygen. There are 3 alarm LED lights on 3 sides of the instrument to increase visibility of alarm conditions. There are 2 audible alarm ports to make it easier to hear the alarm conditions even in noisy environments. The GX-2009 can produce a 95 decibel alarm at 30 centimeters. There is an infrared communication port located on the top left side, which is used to transfer information when the instrument is used with one of the calibration or downloading accessories. The GX-2009 is available with 2 types of clips, the standard alligator clip and the optional belt clip. The alligator clip can be used to attach the GX-2009 to clothing or a belt. The alligator clip can be rotated to change how the instrument is oriented when worn, and the teeth in the clip's jaws prevent the unit from slipping off. The belt clip is used to easily clip the GX-2009 on a belt. There are 3 threaded inserts on the back of the case. These are used to mount the alligator clip or the optional belt clip. The sensor retainer holds the gas sensors in place and snaps onto the bottom of the case. It has 4 diffusion ports, 1 for each sensor, and has recessed areas in it for the charcoal filter and the H2S removal filters. It also has indexing features for the sensor retainer gasket. The sensor retainer gasket seats onto the sensor retainer and seals the interface between the sensor retainer, sensor cover, and sensor cover retainer. The sensor cover retainer snaps onto the sensor retainer. 2 screws secure the sensor retainer and the sensor cover retainer to the case. The charcoal filter disc is located in the CO sensor port of the sensor retainer. It is black, has a woven texture, and is impregnated with a hydrogen sulfide absorbing material. It fits into a recessed area of that port. The CO sensor will respond if exposed to hydrogen sulfide and certain hydrocarbon gases. The charcoal filter scrubs these gases out of the gas sampled to avoid false CO readings. The H2S absorbing material added to the charcoal filter extends its H2S absorbing life. If false CO readings are noticed, especially high readings in the presence of H2S, change the charcoal filter disc. 2 H2S removal filter discs are located in a recessed area of the combustible gas sensor diffusion port in the sensor retainer. The H2S removal filter discs are white when new. They scrub hydrogen sulfide out of the gas sampled to increase the life of the combustible sensor. They darken as they absorb H2S and must be changed when they turn to a dark brown color. The recommended replacement frequency will depend on how often the unit is exposed to H2S and the concentration. Check the condition of the H2S removal filter discs quarterly. The sensors are protected from the environment by the sensor cover, which allows ambient air to diffuse to the sensors. The sensor cover is white and protects the scrubber filters and sensors from dust and water. It fits on the sensor retainer gasket over all the sensor diffusion ports and is secured in place by the sensor cover retainer. If the sensor cover becomes dirty, the response time and accuracy of the GX-2009 will be affected. Replace the sensor cover if it appears dirty. The GX-2009 uses 4 sensors to monitor combustibles, oxygen, carbon monoxide, and hydrogen sulfide simultaneously. The combustible gas sensor detects combustible gas and vapors in the lower explosive limit range, or LEL, with a catalytic element. A sintered metal flame arrestor covers the element and allows ambient air to diffuse into the sensor. The reaction of gas with oxygen on the catalyst causes a change in the resistance of the element, which affects the current flowing through it. The current is amplified by the GX-2009 circuitry, converted to a measurement of combustible gas concentration, and displayed on the LCD. The oxygen sensor is a galvanic type sensor. A membrane covers the cell and allows gas to diffuse into the cell at a rate proportional to the partial pressure of oxygen. The oxygen reacts in the cell and produces a voltage proportional to the concentration of oxygen. The voltage is measured by the GX-2009 circuitry, converted to a measurement of gas concentration, and displayed on the LCD display. The carbon monoxide and hydrogen sulfide sensors are electrochemical sensors that consist of two precious metal electrodes in an acid electrolyte. A gas-permeable membrane covers the sensor face and allows gas to diffuse into the electrolyte. The gas reacts in the sensor and produces a current proportional to the concentration of the target gas. The current is amplified by the GX-2009 circuitry, converted to a measurement of gas concentration, and displayed on the LCD. The GX-2009's liquid crystal display during normal operating mode will show the current gas readings for all gas channels, the current time, battery conditions, and any alarm indications. When either of the control buttons are pressed, the LCD backlight comes on for 30 seconds. Two glow-in-the-dark control buttons are located below the display on either side of the front buzzer opening. The power mode button will turn on the unit as well as the LCD backlight. It is used to scroll through the display mode, reset gas alarms, enter calibration and setup modes with the air button. It is also used to select displayed items and parameters and to save adjusted parameters. The air button is used to perform a fresh air adjustment, adjust or change parameters, and also turns on the LCD backlight. The primary function of the GX-2009's printed circuit boards are to amplify the signal sent to them from the four gas sensors, convert the signal to a measurement of gas concentration, display the gas concentration on the LCD, store peak, STEL, and TWA readings, and activate the alarm circuit if an alarm point has been reached. The circuit board also monitors battery level, battery failure, and sensor failure. They also control the GX-2009's time function and various operating modes. There are bright red alarm LED lights located on three sides of the instrument to increase visibility of alarm conditions. An internal solid-state buzzer is amplified through two audible alarm ports located on the top and front of the instrument and provides a 95 decibel alarm. The buzzer will sound for gas alarms, failure alarms, and as an indicator during normal use in various operating modes. An internal vibrating motor will vibrate for gas alarms and as an indicator during normal use in various operating modes. The two nickel metal hydride batteries supply 2.4 volts to power the GX-2009. The batteries will run the unit for up to 20 hours when no alarms have been activated during that time period. The batteries are designed to be charged while enclosed in the GX-2009, utilizing the GX-2009 charging station. The batteries should not be removed from the GX-2009 unless they need to be replaced because they will no longer hold a charge. The battery icon in the lower left corner of the LCD shows the charge remaining in the batteries. The GX-2009's nickel metal hydride batteries are charged with the GX-2009 charging station. There are two types of charging stations available: the standard AC-powered charging station and the optional vehicle plug DC-powered charging station. The standard AC-powered charging station is available in configurations that charge from 1 to 5 instruments at a time. The single instrument charging station consists of one instrument charging base and an AC adapter. The AC adapter for the standard charging station plugs into a 115 VAC wall outlet and connects to the charging station with a jack on the end of a 5-foot DC output cable. The AC adapter will also work for 100 VAC or 220 VAC if an appropriate plug adapter is provided. Charging stations for more than one instrument include additional chargers that are attached to each other. The same AC adapter can power up to a maximum of 5 charging bases. An optional DC-powered single-instrument charging station is available with a 12-volt DC vehicle plug. The DC adapter for the charging station can only provide enough power to charge one instrument at a time, so the DC-powered charging station is only available as a single-instrument charging station. It uses the same charging base as the AC-powered charging station.